Okay, good afternoon again. How's everyone doing? Let's ask everyone to take their seats. We have an excellent, we are honored to have an excellent keynote speaker for this afternoon. Gregg Brunner is the Chief Operating Officer for the Michigan Department of Transportation. So everything that rolls, floats, or flies in the great state of Michigan, he has responsibility for. Gregg has years and years of expertise in ITS and connected vehicles. Immediately prior to his present position from 2019 to 2021, he led the Bureau of Field Services, where he was responsible for, among other things, connected and automated vehicles and ITS deployment. So hope you have some burning questions on the state of deployment. I hope that the conversations that you heard earlier today will stimulate some thoughts from you as well. Gregg also has a history as an administrator of the Blue Water Bridge, so very familiar with tolling in the other side of OmniAir. So I can't think of a better person to be our afternoon keynote speaker. Please join me in giving a warm welcome to Gregg.
All right, good afternoon, everyone, and thanks again for having me. Again, I'm Gregg Brunner with the Michigan Department of Transportation, and I get the honor of speaking right after lunch. I don't know if it's better to speak before lunch when everyone's antsy to eat, or after lunch when the carbs from the pasta and garlic bread kick in. But either way, I'm going to touch on quite a few topics today, so I'll keep it interesting for you moving forward. And what I'm going to be talking about today is some of the future mobility initiatives we have going on at MDOT. I know I started with MDOT back in the 90s, about 25 years ago, or as my kids would say, way back in the 1900s, just to make me feel old. But back then, when we started thinking about DOT functions, a lot of them were really focused on strictly infrastructure, either just good pavement condition, good bridge condition, allow people to get where they're going. And we've continued to change, to give people what they want in terms of mobility, to help them get where they need to go, how they need to get there, whether it's by car, as has been said before, train, bus, scooter, anything. How do we help people get where they want to go, regardless of mode that we're looking at? And a lot of that relies on new technology, not necessarily just the roadway pavement itself or the bridge going forward. But I've heard a lot of talk today about safety, which I think is fantastic, because that's one of the cores we look at MDOT. We are quite involved in a lot of different safety initiatives out there. Historically, when we start looking at safety, we had looked at taking more of the towards zero deaths approach, where we'd look on a map to see kind of where our crash is happening, what can we do from a DOT side to be able to alleviate a lot of those. But newer initiatives nationally focus more on the safe systems approach, and it's not just what can I do as a DOT engineer to update the roadway, but what can we do working together, whether it be with enforcement, with different modes, with new technologies, education, all of that working together to be able to get to zero deaths. And again, a lot of this safe systems approach doesn't necessarily rely on totally getting rid of crashes, but it looks at how do we kind of reduce the kinetic energy involved with crashes, so that at the end of the day, we all kind of know that crashes are going to happen, unfortunately, unless we can get to autonomous vehicles or other types of things to really limit those. But if crashes are going to happen, what can we do to reduce that kinetic energy so that they aren't fatal, to cause lots of the issues going on? So overall, a big thing we've seen recently in Michigan is the amount of wrong way driving deaths out there. And as you can imagine, on our freeways, if there's two cars that hit head on at 70 miles an hour or more, those are some of the most horrific crashes you can ever imagine. And when we start talking nationally, there's about 300 to 400 of those fatal crashes that happen every year. So as a department, what can we do to alleviate a lot of those? And historically, we'd focus on more static type fixes where, it may be adding do not enter signs, or lowering them to kind of more visible to the drivers, or red reflectors as you're driving wrong way down the ramp. Hopefully you've never seen any of those red reflectors, because it's only if you're going the wrong way. But those types of things. But now we're looking at new technology to be able to do that. We piloted some things around the Metro Detroit area and also in Grand Rapids that really focus on driver communications. In particular, cameras to kind of identify wrong way drivers that are out there. And once those cameras do make that identification, then they can automatically send alerts to our TOCs, or Transportation Operations Centers, and to MSP, or local and Michigan State Police, or local enforcement. To be able to identify the driver out there, but then also to change a lot of our dynamic message signs to note drivers coming in the proper direction of the potential for a wrong way driver. So we're looking at these types of initiatives for wrong-way driving, also on near-miss technology at some other intersections, so that we can kind of be proactive in terms of addressing a lot of these crashes before they happen. So again, these are some of the things we're starting to look at going forward tied to new technology. You also heard some talk earlier today about the work zone data exchange. And when you think of departments of transportation, there's probably two things you think of. Construction, or the orange barrels you see in the summer, and at least in Michigan, the snowplows in the winter. I'll be talking about the snowplows a little bit later in this presentation in terms of some of the technology we have there. But one of the things we've been working on in particular is the work zone data exchange, kind of how we can feed information from our work zone devices to users, roadway users in the area. Michigan's blessed with a law for work zone speeds on our freeways, where 60 miles an hour in our freeways, unless workers are present, then it's 45. So when you start thinking about connected or autonomous vehicles, how can they identify if workers are present or not to be able to accommodate those different speeds? So what we're looking at is communication and variable speed limit signs out there that can identify when workers are present and kind of change that dynamic speed on the sign to allow folks to know what's going on out there. Again, these variable speeds, they are advisory speeds, they aren't enforceable yet. But again, it's just to get more identification about what's going on out there. And we have done quite a few pilots and demonstrations on this. I actually have a video right after this slide that I'm going to show instead, because it'll do a better job of kind of talking through things than I'm going to do. And hopefully this works by clicking the button.
Work zones are getting smarter, and that means improved safety for motorists as well as road crews. The Michigan Department of Transportation has teamed up with General Motors to leverage new technology to alert drivers and their vehicle that they are approaching construction.
Work zone ahead.
We're demonstrating our ability to retrieve real-time road construction data from smart devices deployed along a job site along Interstate 96. We've got lane closure, arrow boards, we've got a variable speed limit sign, we've even got vests that construction workers are wearing to tell our cars where they are on the highway. So we're very excited about this collaboration between GM and Michigan DOT to improve public safety and to improve the awareness of our drivers, our customers, about what's going on around them in work sites.
Recently, an alert system was tested on I-96 in Oakland County, where MDOT is working on adding the state's second flex route. This busy corridor gave the team a chance to test in a highly congested area.
We know there's challenges out there. This is the first of its kind in the United States, actually being done on the road and with a real work zone. So we're happy to have these partnerships because that has enabled us the opportunity to move this technology forward.
The ongoing partnership to improve safety is building on past success. The technology, first tested in November of 2021, can do things like send a signal to the vehicle and driver that there is a lane closure up ahead. The car recognizes that it needs to change lanes when it is safe to do so, and slow down to 60 miles per hour as it enters the work zone. Whether you're working on the roads or driving to work, these partnerships are leading to safer work zones.
People are more and more distracted today on the road, so having that, okay, shake, hey guys, you're going into place, you're going to a work zone, and by the way, they have real mom and pop and people working over there, so keep attention, be safe, and that way we'll have less incident and workers will get back to their lovely one at the end of the day. That's the purpose of all of these.
Crews are still counting on you to do your part. Follow the rules of the work zone by slowing down and paying attention. The driver is still the most important safety feature of any vehicle.
All right, so that's kind of one of the demonstrations we did about a year and a half ago, it's about 20 minutes south of here on a construction project that we're building on the I-96 corridor. But what you saw in that video was being able to identify road workers too, through transponders they have in their vests. That's a technology we brought forward to this past year, and again this summer, that we're looking at is being able to push out that information when there are workers out in the roadway. that can be pushed then to vehicles through the work zone data exchange. Again, because they are vulnerable roadway users, and that's one of the key focuses of the safe systems approach, is being able to identify those folks that are out there, and hopefully people can pay attention and slow down, because at the end of the day, we all want to be able to get home. And just beyond that, one of the pilots we're looking at this year is then how can we also push that information out to commercial vehicles, drivers for their in-dash navigation system. So that's one of the things we're working on this summer going forward. And again, continuing to just work with OEMs and suppliers to be able to implement this technology and make it a little more mainstream in terms of what we do across the state and across the country. All right, the next big thing we're working on is electrification. And like I said, when I started back in the 90s, if you would have told me MDOT would have been involved in electrification, I'd have said you're crazy. We don't own gas stations. We don't do anything that really propels vehicles forward other than building a big hill they can go down, I guess. But again, that's where we are today, and we're responsible to roll out the NEVI program, which is the National Electrical Vehicle Infrastructure. So what's going on is we released round one of the NEVI program, which is about $40 million for sites across Michigan. I can show them a little better on this map here, but we have EV corridors across the state. And for those of you not familiar with the NEVI program, what it does on these corridors is locates a charger approximately every 50 miles within 1 mile of the freeway. So what we did for our first portion of the contract was let out those different locations. It's a design, build, operate, maintain contract where vendors could bid on those in terms of installing in those different locations. As part of this, we'll be installing about 40 nodes across the state this summer, so hopefully we'll be having ribbon cuttings in the next couple of months for a lot of those locations. But again, you can see by looking at where they're located on the map, it gives people the flexibility to drive across the state without kind of having some of those concerns associated with EVs and having to stop to charge or where can I charge going forward. Round two will be coming shortly on those, but again, those are tied to when you have to stop to fill up. The other thing we've implemented in Michigan, and we were the first state in the country to do this, was inductive roadway charging. This was announced or actually completed for a small portion in Detroit, but a 1/4 mile last fall. And we have another project coming up 3/4 of a mile in Detroit adjacent to that later this fall. So when I start talking about inductive roadway charging, that kind of alleviates the need to have to stop to charge your vehicle. The use case we're looking at for this is more based on transit in the Detroit area with an EV bus. And it comes with two types of charging capabilities. There's dynamic charging and static charging. So when you start thinking about how a bus operates, of course, they're driving down the road. So they can trickle charge as they're driving down the road, and then once they're stopped for a stop to pick up or let off people, with that static charging there, that can provide a more full of a charge. So we're interested to see how this works out overall. When you start looking at the technology itself, it's with a company called Electrion. And what we had to do here is actually it can be put under any asphalt pavement. More or less, you just mill a couple inches of asphalt off the roadway. You can put down these electric coils, and then you can just pave asphalt back over them. So from a construction standpoint, it's relatively easy to be able to do. I know this Electrion also has kind of a test patch over at Mcity if you're headed over there later today, where you can kind of take a look at things there as well. But again, this is the first one in the country we've been able to do. We're kind of monitoring how things go here and continuing to look at additional use cases on where it can be rolled out at other types or locations, such as rest areas or waiting for tolls at some of our international bridges or other types of places around. So again, as I talked about, a lot of this initially will be aimed at transit in terms of how we're doing it, but the potential's there for cars. I saw a demo at their facility where a car drove over 100 hours without stopping. Of course, they had to stop, well, I should say that they had to stop to change drivers just because it was around a circle test track, and God only knows how you could drive around a circle test track for 100 hours without getting sick. But again, overall, by the end of that 100 hours, everything was still on full charge, which was fantastic to see. And again, that alleviates a lot of the concerns or anxiety some folks have with transitioning to EVs. All right, now the other thing, I thought I'd throw a little bit different slide in here tied to winter maintenance, which is probably something that a lot of you don't deal with. I know I've talked to folks here from California and other spots, and even the folks here in Michigan. The last thing you probably want to hear about right now on a 70-degree day in the spring is more about winter and snow, right? But when I start talking about winter maintenance, a lot of people, we have a lot of armchair quarterbacks out there that thinks they're experts in how to plow snow. I know every time it snows out, I get a call from some guy that plows his driveway that tells me a better way to do it, either putting down more snow, more salt, where to push the snow, those types of things. So one of the things we're looking at is new types of innovations and how we can remove snow from our roadways to keep things safe. These are a couple that didn't make the cut, but again, I just thought it was funny. When we start talking about winter maintenance trucks themselves, they are pretty complex, and we've approached it initially, at least on the mechanical side of things, where you can have kind of a normal truck that we use as a tandem axle snow plow. It holds about 11 tons of salt. For some of them, we install those wing plows on the side, depending on the route they're on. That wing plow will come down and give you a little extra width when you're plowing to plow the shoulders. So if they're on the inside lane, we can add a left wing on it. If they're on the outside lane, we can add a right wing on it. We do have some that we call our bipartisan snow plows. They have a left wing and a right wing on them, so got to keep everybody happy. But again, they're all set up for different routes or different locations in terms of where they're at. Quite a few of the other things that are involved, we had temperature sensors and other things on there just to get pavement data. And a lot of this I'm talking about right now is just give you the background on the mechanical side of things, and then also salt dispersal systems in terms of putting down the right amount of salt at the right time. Environmentally, that's something we're very conscious about because salt has chloride, and chloride's not the best for the environment. So we're trying to balance, when we're applying salt, the economic side of things, that there's a cost to it. I think this year we pay about $70 a ton for salt. There's the environmental side of things. And then just the overall efficiency. If you're not putting down enough salt to melt some of the ice, you're wasting your time. And if you're putting down too much, you're also wasting a lot of salt and pushing it into the ditch, which leads to environmental concerns. So again, there's a lot going on when you start talking about winter maintenance that people aren't as familiar with. But we've kind of adapted technology to this as well. And about 10 years ago, we added AVL systems, automated vehicle location systems, to all of our snowplows in the state. They gave us an idea of not only where the snowplow was at, but what they were up to in terms of if their blade was down to plow snow, if they were applying salt, and then also a dash cam in there that gave our supervisors kind of an idea of how the road conditions looked at that time that could be used around the state. What we've done more recently is then added those snowplows to our website. MDOT has a transportation information public website, michigan.gov/drive. So it has construction incidents. It shows where our snowplows are. And what probably got the most fame out of all this is we had a public competition to name our snowplows. And the responses we got were fantastic. There's Darth Blader, the Big Leplowski, and about 300 other fantastic names that I don't know, people a lot more creative than me came up with. But what that's done is drawn a lot of attention to our website in terms of where snowplows are at, when they're out. But you can also look at these road conditions ahead of you before you plan your travels. I know if you wanted to go out snowmobiling, you can use some of these to see where there's actually snow in Michigan to be able to get there. So again, some side benefits that were noted. But when you start talking about the snowplows themselves and the amount of technology we've added to them, it almost starts to look more like an airplane cockpit than it does, just a standard truck. When you look at the number of joysticks they have in there to control the different wing plows or underbody blades, the salt dispersal systems they have, maintenance decision support system, which I'm going to talk about in a second, display screen, which shows radar and recommendations for treatment. So as much as we discourage distracted driving, the one thing I like to remind people here is they're out there doing their jobs, so give them as much space as you can to do their job to keep the roads safe for all of us. Because as you can see by looking here, there's a lot going on inside these winter maintenance trucks, a lot more than people take into account the ones that are out there just plowing their driveway every day. So kind of the next step where we've taken that from a technology standpoint is we've incorporated a maintenance decision support system into our snowplows and just our winter operations as a whole. And what that does is combines technology from a lot of different places. For those of you familiar with our ITS system, we do have environmental sensor systems located around the state that record environmental conditions, pavement temperatures, air temperatures, frost depths, those types of things. So we have that weather information. We have kind of the standard radar from the National Weather Service. So we can combine those two types of weather information, but then we take it to the next level for a lot of these where we input specific routes on there. So it can say I-75 from this segment to this segment, and this location is concrete. And of course, if you have concrete or asphalt, that impacts kind of how fast the ice or snow will melt. In particular, if the sun's out, the darker color of the asphalt is going to absorb sun more, warm it up some, so things move a little faster. So it takes into account pavement temperatures that we pick up from the trucks as we're driving by. So lots of different data sources here. And what it does is gives us a predictive model for each specific route, for each specific driver looking forward, and kind of has an hour-by-hour breakdown in terms of what they should be able to expect when they're out there on the roadway, given the potential weather precipitation that'll be coming. And it gives recommendations down to if they should be plowing or not, if they should be salting or not, and if they are salting, they should be applying at whatever rate, whether it's 100 pounds per mile, 200 pounds per mile, or even more than that, just depending on the conditions that are out there. And it's something we kind of keep an eye on throughout the year, working with the vendor to make adjustments to some of those forecast data, but it's really taken our operations to the next level in terms of winter maintenance and what we do. So also tied to winter maintenance is the amount of salt that we use. And again, as I mentioned, we work closely with our sister agency of environment on kind of reducing the amount of chloride we have out there. But when you start talking about salt in Michigan, that's big business for us. Overall, just to give you an average, we spend about $100 million, MDOT spends about $100 million a year on winter maintenance. And about a third of that, $30 million, is on salt. So salt's a big ticket item for us. So of course, knowing how much we have is important. So what we started doing even more recently is using drones or UAS to be able to scan our piles of salt in our bins to be able to tell us what inventory we still have out there. So again, we're looking at these new types of technology across the board to help make us more efficient in terms of what we do. And kind of the last thing I was going to talk about, I know it's been talked about earlier today too, is road usage charges. And there's a lot of different states that are looking at things for road use charges. Probably on the West Coast, there's a few that are looking at, or have been for a while, looking at pilots. I know Hawaii's implemented something. And of course, Hawaii is going to be a lot different than Michigan is in terms of road usage charges and how that would work. But at the end of the day, we're looking at kind of what can we do moving forward to replace the standard gas tax that we have on vehicles, with vehicles getting more efficient, or EVs or other types of transportation out there. What can we use to kind of model how we should collect funds to kind of maintain our roads and bridges and other transportation assets that we have. We've recently done a tolling study for the legislature that looked at potential tolling routes. When you start talking about Michigan in particular, it's not a real toll-friendly state when you start talking to the public. We don't have any toll routes here for roads themselves. We do have them for our international bridges and the Mackinac Bridge up there. But again, I don't know. You drive to all of our local states and tolls are fine there. But from the public perception of tolls, it hasn't always been the best in Michigan. So now we're looking at road usage charges as another potential terms to kind of replace the gas tax in Michigan. So what we've done is we applied for a pilot, and it's a 3-step pilot in terms of what's going on. The first phase of this pilot was just to do kind of a random survey of folks to get their perceptions on road usage charges. Number one, if they knew what it was. Number two, if they were receptive to that in terms of replacing the gas tax, and just thoughts in general on that. So that wrapped up a few weeks ago in terms of what we learned. We learned anybody will take a survey if you give them gift cards. Part of the rollout of that was that we would give a $10 gift card if you completed the survey. And I think as part of the grant we got, there were up to 14,000 cards we could give out. We went through those in less than a day. But overall, we got about 30,000 responses. We're still scrolling through all those, scrubbing the data to make sure they're all accurate. And then kind of compiling the results to see overall, where do people stand in Michigan tied to road use charges. The next step is to develop more terminology tied to people. If I say ruck to someone right now, they think I'm a dog or something, I guess, I don't know. But when you start talking road usage charges, they'll how do we better help folks to understand what that is, how they're charged, and kind of where we would go from there in terms of dynamic charging through telecommunications, or kind of manual responses monthly, or vehicle registration annually, or how that would all kind of work. So we're looking at really the communication standpoint next, and kind of the third key part of the project is working with transit agencies in the area. And one in particular in Metro Detroit, the other in Grand Rapids, just to look at kind of, if you started looking at road usage charges, what would sway people to use either public transit or different types of transportation services. So again, that's going to be kind of the third step, which is a little bit farther out after we complete phase 1 and 2. Again, that one's going to roll out and probably be completed in 2025. And right now there's a lot of different states looking at this, and when you start thinking about Michigan in general, you know, a lot of this would be kind of focused on Michigan residents themselves. When you look at Michigan in general, it is a big tourist state. And not only that, it's a big international state in terms of commerce with Canada. It's about a third, I think it's a third of all commerce from Canada runs through one of our international crossings in Michigan. Even though we do just have those bridge borders right now, which is kind of fascinating when you look at the amount of other states that have international ties with the Canadian border. But again, it gets down to interoperability. So we are working on grants with other states, kind of how would we make this an overall interoperable system. A lot of that's been talked about earlier today too. So we're still kind of in the learning phase here. But again, coordinating with a lot of other states around the country in terms of what is the best way to approach this, being that it's probably where we're gonna have to head somewhere down the road. So with that, I think I have a few minutes for questions. I will warn you though, I'm probably not as techie as some of you in here. I dabble in a lot of different things. I like to tell people I'm the jack of all trades and master of none. So if you dive too far down in the weeds, I can get you an answer. But with that, I can answer any questions you had. Yes, sir.
So a few questions. For the work zone, are you doing anything to validate the information coming from the roadside devices?
For the work zone's data exchange, yes, that's what we're working on right now through our ITS program office. So right now all the data is consumed by our ITS program office, and then we're using that to push out to folks from that standpoint.
And then on the salt measurement with the drone, are you using that data to validate invoicing?
Not yet. Right now we're using it more at the end. Since it changes so much, since our inventory changes so much, pretty much every time it snows, we're using that to validate kind of at year end, not at the actual invoice itself, but once we get to the end of the year with what's remaining in the salt bins, we have a detailed inventory of what they've used throughout the year. We know what they started with. We know the tickets they got, and then kind of using that as a year-end validation, not necessarily an invoice validation.
Okay. And then the third question, as far as the snowplow operation, are you headed down to a path where some of that treatment application is automated?
Potentially, we're looking at that. We're looking at quite a few things in terms of treatments right now. One of the other things I didn't mention is we're also looking at different types of liquids that we can use on our roadways in lieu of rock salt itself. So there's actually legislation that asks us to do a pilot on using agricultural byproducts instead of just rock salt itself. So we're 3 years into that test right now. We're looking at specific corridors around the state to be able to do that. We haven't, to your original question though, we haven't got to the point of automated adjustments to that, just because the one thing we have learned is a lot of that comes down to drivers themselves and the experience they get on the roadways, that adjustments have to be made if they come to different areas where there may be additional snowpack or other types of things, where they can adjust the dial to increase their rate, or they have a boost button in there if they really want to dump it out at intersections or other types of things. But again, that's maybe something we look at down the road, but we aren't there just yet.
Yep, this is Stella Joseph, the chairperson for the RUC OmniAir. So you mentioned that you've done some pilot or starting a pilot, maybe just starting with surveys. Do you have any plans for actually some implementation of a pilot possibly?
Not yet on the implementation side of things. That's one of the grants that we are pursuing right now that's out there, but right now we're more on the fact finding in terms of an actual pilot itself.
Great. And I'm glad to have you as a stakeholder. We are started some of the stakeholder engagement, so definitely will touch base with you, Gregg.
Okay, sounds good. Thanks.
Yeah, thank you for the nice presentation. I'm Hideki from Toyota. So I have a question like, are there any pilot trials to prevent or reduce the amount of speeding? Because when we see the speed limit sign of 70 miles per hour, somehow we think it's okay until 79. So I just wonder, like, any speed is one of those like 5 pillars of USDOT work. I wonder.
Yep. There's a few things that we're working on right now. One of those is dynamic message signs in our work zones. You may see them in some local areas or others that give you this. It tells the speed limit, and then below it in dynamic, it tells you what you're driving. And those have been very promising in a lot of the work zones. We started implementing those last year and quite a few around. The other thing that we are doing right now is there's legislation in Michigan looking at automated work zone enforcement. Where again, in lieu of having work zone enforcement with state police out there pulling people over that are speeding, we would have a radar camera, more or less a van parked out that could identify license plate reader, identify those that are speeding, and then send out citations. Again, the goal is not to collect money and send citations. It's more for compliance, for people to slow down where they are in our work zones, again, to keep people safe. The way the legislation is written right now is what would happen with those dollars is it wouldn't necessarily go to us for infrastructure work or to MSP or anywhere else. It would create a safety fund overall to look at ways to improve roadway safety. Some could be to address or to pay for that automated work zone contract that we would have to have, but other safety initiatives to tie specifically to work zones. So there's quite a few different things we're looking at. Again, since the pandemic, people think they can drive a lot faster than they should be right now. And I don't know how that started, but again, we have seen, as a result, we've seen the number of fatal crashes on our roadways go up quite a bit. So we're always looking for different and new technology that we can use to incorporate, again, to help reduce those speeds out there. And a lot of that gets back to that slide we had focused on and some of the things I touched on today with Safe Systems approach, where the DOT can do so much, but it's about all of us working together to improve roadway safety. And again, that's kind of something that we need to continue to coordinate on to move things forward. Not seeing any other hands. So again, I'd just like to thank everybody for having me, and I'll stick around for a bit if anyone had any follow-up questions.
That was fantastic. Thank you. Can we have a hand for our keynote speaker? And so excited to see that there is so much happening in the state of Michigan. I think it gives a solid foundation for where we're going to go in our next panel, which is what's happening in the future. What are some of those future use cases we can look to? What's happening with 5G MEC, and how are we addressing vulnerable road users like bicyclists? All topics for discussion in our next panel, led by Mr. Bill McKinley from Keysight Technologies. Mr. McKinley is an OmniAir board member and a long-standing supporter of connected vehicles. He leads the connected and automated vehicle testing for Keysight Technologies. Hails from Scotland, so he has traveled a long and weary mile to be part of this event. And I'd like to welcome Mr. McKinley and panel 3 up to the stage.
Yes, good afternoon, everyone. Bill McKinley from Keysight. As Jason mentioned, I am from Scotland, so if you have trouble with my accent, then all I say is I don't have an accent. Everybody else does. But if you do have problems, just let me know, and I'll do my best to translate. Yes. I got the last one. Are they going, oh, we're missing someone here. Okay. Okay, so yes, as Jason mentioned, we're going to talk about the future. The brief was charting the course of connectivity and digital infrastructure. And so we've got together a very talented panel, and then it's a combination of, I think, really key actors and stakeholders in the future of our industry here. We have government representatives, we've got a network operator, we've got academia, we've got an infrastructure owner operator, and we have a representative of a vulnerable road user segment who we're all interested in keeping safe. So it's a nice group of actors that can comment. Let me quickly introduce everyone. I'll do my best to represent their title, and I'll let them do the rest. So in no particular order, we have Nick Hegemier from DriveOhio as a center formed in Ohio DOT focused on smart mobility. We've got Arpan Kusari, who's from UMTRI, an assistant research scientist in the engineering group. We have Kirk Niebert from T-Mobile, product management, lots of experience in connected vehicles and connected infrastructure. Kellen Pucher from Spoke Safety. As I mentioned, he's involved in vulnerable road users, in particular cyclists. And I'm a cyclist, many of us are, hopefully. And so we're all very aware of how dangerous it can be with bicyclists on roads. And then finally, but not least, obviously, Suzanne Sloan. We've met Suzanne before, but Principal Policy Advisor, USDOT in the Volpe Center. So what I thought I would do is, with the brief, I thought, well, what exactly is connected infrastructure? So I thought I would use my company-approved AI assistant to come up with a whole list of things. It did. I amended it to represent kind of where we are. But rather than go through the list, I kind of represented it in this kind of circle, because each of those elements come together to provide us with the connectivity and the infrastructure. But importantly, they all need to work together, and interoperability is kind of the key. All these things need to work for us to enjoy the benefits, hopefully, of the safety. And I just took a couple of examples. I'm not going to go through many more slides, but I wanted to make sure that we represented an element that balances with our panel. So we have networks, of course, and we have Timo here who can talk about that. But not just terrestrial infrastructure. We see the future of non-terrestrial networks, such as low Earth orbit satellites. So that's a component. We've got roadside infrastructure, so Nick can comment on that. The VRU protection is part of safety and security. We've got, we've had a lot about security from SCMS, from companies like Sysoltech, but cloud services, but also we've got IoT, or when the connected vehicle is part of that. So I think we've got a lot of material to cover. We don't have a great deal of time. So what I'd like to do is ask each of the panelists to maybe introduce themselves briefly. What is it they're working on in terms of what element is part of this digital infrastructure, and what and maybe we can talk about the state of the art, and then we can pass it on. So Arpan, perhaps I can start with you as being closest to me. Thanks.
I drew this short.
Yeah, you were last up on the stage, so sorry. Yeah.
Hi, my name is Arpan Kusari. I work at UMTRI. I'm a research faculty over here. And my previous experience was at Ford for 5 years, where I worked in the autonomous vehicle software pipeline. So if you have to take a look at the things that play with the connected vehicles and the automated vehicles, that shares a huge realm, right? So when you have this message passing from the connected infrastructure to the automated vehicle, what do you pass? How do you pass that? Of course, AI plays a role in terms of the edge computing, but even then there is a lot of uncertainty. So how do you deal with that? So it's a lot to do with not only the physical part of it, but also how do you pass that information over to that automated vehicle so that it can make an intelligent decision. Most of the times it might happen that those two sets of information might not coincide. They might actually be at loggerheads. So what do you do with that? How do you kind of reason it out? So most of my research kind of revolves around that theme. Happy to be here.
Well, thank you very much. Kellen, want to take that?
Hi, everyone. My name is Kellen Pucher, and I am now the Vice President of Partnerships for really all things technical through to business development for a company called Spoke Safety. And we are really a VRU or VRU to X focused company. So the application of V to X technology and other communications and sensor fusion, in particular to that vulnerable road user segment. Prior to joining Spoke, I was with Panasonic and their VDEX division. Hey guys, I see some of my former colleagues there in the back for the better part of 6 or 7 years. So I'm starting to feel a little bit like maybe a young veteran in this V2X space.
Okay, young veteran, I like that. Thank you. Suzanne?
And I'm Suzanne Sloan with the U.S. Department of Transportation. Actually speaking here on behalf of John Harding, who was here but had to leave for his flight to get home for some other things going on. John's really in charge of the Roadway Digital Infrastructure Initiative at the USDOT, and it's a pretty important initiative from the federal highway perspective because we've always been pursuing the concept of real-time system performance management. So how do we manage the performance of the system in real time? And of course, data is so critical. The data exchange, the data interfaces, how we make this happen. And we always thought V2X would bring that for us, that ubiquity of data. But in the interim time period, so many other sources of data have shown up. So many other services have been enabled because of all of that data. And so we see ourselves both managing things differently, as well as still challenged by the inability to kind of really get at that real-time system performance. And so from John's perspective, the roadway digital infrastructure work is really sort of the marrying of the humans in the organizations with the assets and the physical elements together to see what we can really achieve. And so I've been attached to the ITS architecture and standards work for many years. And as Bill's slide showed when he first started, it really is a mix of components that come together as well as the organizations and the governance and everything else. And so to the extent that we work on the initiative, I'll be working on the architecture and standards side of this whole thing. And Bill, John did say that in that middle space for interoperability, which of course is my favorite place to play, you've got a car, but you need other things in that middle there.
I accept that, yes, I accept that.
Yeah.
Thank you.
Thank you.
Kirk?
And for anybody looking at the previous slide, I am not Kellen Pucher. I am Kirk Niebert with T-Mobile, and we have been involved in this space for a while. And when Bill sent over the slide showing all the different areas where the ecosystem partners play, I looked at that slide and thought, we really play in almost every one of those areas. I mean, obviously, as a mobile network operator, we're focused on the network V2X component of how we can provide these use cases. And I think that's been one of our biggest challenges, frankly, when we have these conversations with public sector, with USDOT, with state DOTs, about what is CV2X, right? Because I mean, everybody kind of focuses on the PC5, the direct V2X, which has its use, absolutely. I mean, in terms of safety critical applications, nobody's denying that. But from a mobile network operator perspective, we're trying to show the viability of using network assets to be able to provide some of these use cases that may not be safety critical, but are more safety enhancing, safety awareness. And we feel like there are a number of areas where we can play a vital role. We also see the need to work with partners in the OEM community about how do we leverage technology that already exists in the vehicles, whether that's a 4G modem or a 5G modem, to be able to enable some of these use cases. We know that putting direct V2X communications in cars is a costly procedure, and we've talked about all the uncertainty around why that isn't happening faster than we'd like it to. So again, as a mobile network operator, we kind of see ourselves as a bridge, if you will, where we have technology that can be delivered via the UU channel, via the network V2X components to deliver alerts into cars, but we need partnerships with the OEMs to, I mean, we've got the technology in there. I think we figured out how to send the alerts, but that piece of receiving the alerts in the vehicles is still kind of missing. And we're trying to bridge that gap through things like providing apps on smartphones that can receive these alerts. We're cognizant of the distracted driving aspect of another app in the car to potentially distract you, but it's the only mechanism we have right now to deliver those alerts. So again, it's not the be-all, end-all, but it is a bridge to hopefully get to where we ultimately want to be, is just having those alerts show up directly into the infotainment systems. And we're working with partners to hopefully be able to enable that.
Yep, thank you. Kirk or Kellen? Okay, Nick, thanks.
Yeah, thanks for having me. I'm Nick Hegemier, Managing Director of Infrastructure for DriveOhio. We were formed back in January of 2018 as the Ohio's one-stop point of entry for all things connected, automated, electric, and now UAS as well. So sort of a lot of things to unpack here. And when Bill first presented the slides to us, my thought was he wanted us to pick a category. And my category fell right in the center, sort of like Suzanne's. I want the interoperability. And I don't want the interoperability from... Well, I don't want to just focus on the interoperability amongst devices that we've been testing this week, but devices and communication mechanisms to get the information to the public. So when I think of CV2X, I think of low latency applications. I think of, first and foremost, the 350,000 intersections that we have in the nation. You know, that's a big challenge right off the bat. And I don't know that we need to take on any additional challenges for CV2X. If we can focus on connected intersections, and I think we have a clear pathway right now. All the stepping stones are there. We just need to execute them. We'll get to where we want to be, and then we can start focusing on some other low latency things. We talked about MNOs. What can the cellular providers provide as far as getting information to us that may not need to be low latency, but still needs some form of transmit receive capability. So we still need to communicate with the system, and the system needs to communicate with us. And then I also think about NTN, so your satellite systems. You know, those are typically one-way forms of communication. But if you know where you're at, and you know where, and you can receive information about what's going on in your area, that may be all you need for areas where cellular coverage may be lacking. I know there's a rural Ohio is predominantly, you know, there. You know, we have lots of hills, valleys, terrain where 5 megabits is a stretch to get. 5 megabits per second is a stretch to get over cellular coverage. So what can we do with satellite, and how do we bring all of those into the vehicle for one complete system, so that if you wanted to, if you were receiving all three messages or three separate messages for one common application or one common issue, the system within your vehicle would note that those messages were about the same thing and just give you one alert.
Yeah, that's some great points. Actually, the next question I had was, can you identify the challenges that, now you did a great job, Nick, and just kicking that off was a great segue. So perhaps I could go back down, and Arpan could be last this time, give you a break. But Kirk, if you could, you maybe touched on, but I'm thinking from your standpoint, from a mobile network operator, you did touch on the PC5 UU thing, but in terms of the holistic approach to all the components need to work, what do you see are let's say the highest priority challenges that you would like to see this group of people work on? Because we all want to see this coming out, being a business that saves lives. We just don't seem to be getting there over that line. But what do you think are the major challenges ahead?
So when I go to conferences like ITS America and TRB and interface through 5GAA with USDOT, it all comes back to me to the chicken and egg story. Who's going to deploy first? Is it the OEMs, or is it the infrastructure? Or is it the public sector putting infrastructure in? And I don't know that we really have an answer to that question. I had dinner last night with one of the OEMs here in Detroit, and I asked him that question, and he said, we're not going to be the first. We're not going to be the first to deploy until we know that other OEMs are doing it, until we know that there's infrastructure out there to deploy it in. And that's been the biggest challenge. How do we move the needle to get somebody to step up and say, okay, I am going to be the first? And I think USDOT is doing a really great job in terms of trying to seed funding to public sector through the different grant programs that they've established. We are partnering with University of Washington, one of the recipients of the Intersection Safety Challenge. We're partnering with City of Bellevue, who received a Safe Streets and Roads for All 2023 grant to deploy more infrastructure. So I feel like public sector is going to have to take the lead, but I do think there needs to be more incentive on the OEM side. We kind of talked about like the carrot and stick. Is that like, is there a stick option through more mandates from NHTSA? Is there a carrot option through some type of incentive to get them to deploy? I don't know what the answer to that is, but to me, that is the biggest challenge. I mean, we have the technology, we know that we can do it, but getting somebody to step up and be first is where we need to go.
Yeah, I was conscious of comments from John Quant earlier, whose background in Ford, and it feels like the OEMs, in my opinion, are eager to present this technology because it makes things safer and so on. But they are, I would say, I don't know, conscious of, they want to push technology too far because a lot of regulations in the OEMs, and they have a cautious nature overall. So I don't know how to break that either, Kirk. It's a great point. So,
can I jump in on that?
Sure,
because I want to key off of what Kirk is saying. There's this question about who's going to go first, and at Spoke, we're becoming decreasingly interested in the chicken and the egg argument, and quite frankly, we think that the vulnerable road user might go first, and we're trying to be that company. So first, if you'll indulge me, I'll just kind of tell you a little bit from a personal perspective about why those of us that founded this company are so intent on vulnerable road users as maybe the first mover in V2X and V2X-like communications with the MNOs. Of the three of us that are domestic in terms of the executives for the company, each one of us have had our father or father-in-law struck and killed while riding a bike. So you don't want to have had any of us as sons, I guess, is the prevailing message there. So we're really building this product, the products that we're working on, which are V2X-centric for ourselves and our loved ones, first and foremost, right? But to your question about kind of the problems, let me reframe those as the business opportunities that we see as kind of a private entity, right? On the one hand, when we look kind of nationally at statistics around roadway fatalities, there's I hate to call it good news, but a good news, bad news kind of stagnation there, right? We're pretty much pegged to this 40,000 per year figure. Good news in the sense that maybe it's not necessarily trending up, but bad news in the sense that we don't yet have ubiquitous V2X technology that's bringing that down to zero, right? Which is part of my own personal goal. I want to see 0 deaths on our roadways by the time that my young ones are able to actually drive. And I think we all in this room believe that V2X is going to be instrumental in driving that figure down. But when we look at the vulnerable road user community, it's not the same story. So from 2010 to now, we're actually seeing about a 40% increase in the number of vulnerable road users being struck and killed on our roadways. And all of that is set in the context and a lot of national messaging from the federal government, but all the way through kind of to your local municipalities about this desire to get more and more people out of single-use commuter vehicles and into micromobility as a viable alternative, right? And I think we're all aware of why that would be a good and positive thing. But on the one hand, vulnerable road user deaths are increasing at the same time that we're asking more people to adopt e-scooters, e-bikes, bikes, et cetera, for that kind of local community transport and replacing a lot of that. So anything that we can do to inject safety into that equation, especially when those vulnerable road users or potential vulnerable road users are saying the #1 reason that they won't replace some of their trips to the grocery store with an e-bike is because of the perception of lack of safety. So anything we can do in that space to kind of bring that about and really catalyze that, I think is going to be a major needle mover for us. And then the other thing here is this chicken and the egg argument, right? So not to point fingers at anyone, right? But a lot of the automakers are keeping the V2X dream very much alive by supporting R&D efforts internally, collaborations even with other automakers, engaging private industry and the M&O networks, and even supporting a lot of the publicly funded pilot activities. But no one's been willing, absent a mandate, to actually kind of place a stake in the ground and say, in this year, in these models, we're going to deploy at scale. And as a result, you get a lot of reticence from other automakers to adopt and to bear some of that initiation cost, because V2X only works when you're talking about a ubiquitous and interoperable kind of paradigm. And then that then leads to, another chicken or egg, which is maybe less than ideal investment in public infrastructure, even at intersections, as Nick had mentioned, to create kind of that reciprocity for any V2X units that would be deployed. And then that ultimately leads to questions nationally about, what have you as an industry been doing with the spectrum and resources that were allocated to you back in the late 1990s, right? So we're interested at Spoke, and speaking selfishly for myself, in really kind of getting off the porch and putting this in the field. And we think that vulnerable road users make sense because it is a group that desperately needs the safety, that we want to incentivize to get going and get mobile, and also who are willing, quite frankly, to bear the cost for even marginal improvements in safety. So one anecdote that I like to share as somebody who's maybe not a road cyclist, but is a mountain biker. Just a few years ago, I went out and spent like $300 on a top-of-the-line helmet for my mountain bike. And just 2 seasons later, hadn't yet had a crash, helmet was in great working order, I'm happy to report, they came out with this new technology called MIPS, which is really nothing more than rotational padding underneath the hard shell of the helmet that could maybe incrementally drive down the probability of a traumatic brain injury in the event that I crash. So what do you think I did? I was back at my local bike retailer spending another $300 on a premium helmet, because the cost calculation in my head is, in the event that I do get in that collision or I crash on the trail, anything I can do to bring down even fractions of a % of my probability of injury, I will spend money on. So our goal, quite frankly, is to get M&O-backed VRU2X, V2X technology in an aftermarket safety device embedded in e-bikes, in e-scooters, and to launch it as early as 2026. And thank you for coming to my TED Talk, sorry.
Wow, said with passion, that's for sure. Suzanne,
I'm actually glad you jumped in, because I was going to point to you specifically in my remarks about the chicken and the egg. The one thing that we're forgetting here is the aftermarket safety device. And a number of you in the room have actually thought about that, if not actually started working on that. And that's a really important installation, especially because a lot of IOOs can actually equip a lot of their vehicles right now without having to buy it fully incorporated from the OEM. I mean, we do want it from the OEM. The ability to get the information off the CAN bus is incredible. It gives us such a finer grain understanding of the situational awareness of around us while we're driving, as well as that data coming in through the infrastructure for that system performance. And so, Spoke is a great example of taking the concept of a lighter of OBU and creating it that is specific to the logistics and the movements associated with a bike within a traffic environment. So that's the good news. In terms of thinking about some level of acceleration, we can look to aftermarket devices. But Bill, getting back to your bigger slide, beyond just the V2X element of this, I think we at the DOT have recognized that once you get past that V2X type data, there's so many other things that are still needed to really kind of pull the concept of digital infrastructure and what it can enable to really move forward. And some of the key things for the Federal Highway Administration, in addition to thinking about the connectivity gaps that Nick was just describing, is the fact that our systems outside of transportation, even within transportation, are growing in number, and the number of interfaces are growing. And just trying to keep up with that, deal with that, and try to figure out what's trusted, what can be brought in as an integrated interface is really important, and something that takes a lot of effort. Right now, when you look at a lot of the infrastructure organizations that have to manage based on all of this data, the systems are not standard, and the information from the systems is fairly inconsistent. And so you can't really make as much opportunity off of that data as we'd really like to. And what's even worse, in some cases, the data is just siloed, and you can't figure out how to get it out of one place to another. So, you know, kind of what Kellen said, there's a lot of opportunity to do this differently and really realize a different future around mobility and accessibility for transportation. But I think we need to really kind of focus on how we combine the physical, the digital, the data from all the different kinds of sources that we can get it, you know, based on greater connectivity in the future from multiple sources. How does that all come together? Mm-hmm. And so I think that's a really big vision, but it's a really big challenge.
Arpan, go ahead. Yep.
I was sitting here listening to you guys, and for my point, it's not the data, right? Data is good. Information is what we are after. We are not after data. Data is there. Like, there are petabytes of data everywhere, right? And the jump from data to information is not a very clear-cut. There is not a very clear-cut path to it. Let's take an example of any sort of AI system which classifies vehicles, right? It's a very simple thing. It looks at the camera images, classifies that is a vehicle, right? And it's going through the intersection. Now, what do you train it on? You train it on images, right, of vehicles. How many vehicles do you train it on? You train it on thousands and thousands and thousands of such camera images. Now, you come up with a new sort of, let's say, a popular truck model which looks like DeLorean, and I shall not name the name. Right, and now you bring that up and you try to classify it. Your AI tells it is something else. Probably it is or it cannot even recognize that it's a truck, right? So what happens in that case? So the jump from data to information is not always there. Let's talk about VRU. You have, again, classified an image of a pedestrian. Now you are classifying an image of a pedestrian with a stroller. Now that person changes the style of the stroller, changes the t-shirt, has different kind of winter wear. There is snow in the background. Now that amount of complexity, it just grows and grows and grows. And it's not linearly increasing. It's probably exponential. So we are stuck on this out of distribution question. Like, how much do we need to train? Because here the data is the model. So there lies a problem of, of course there is data, and data is great, right? Sensors, you can place it in every intersection. I'm also part of the Safety Intersection Challenge as part of Deloitte's team, and we are the academic partner of this, and we keep on talking about it. And then there is the sensor fusion part of it, right? So you are fusing different sensors. All of those sensors have blind spots in terms of what they can and cannot do. And now, once you're fusing that thing, you are trying to get that information to the person, to the user, in a certain amount of time. And that amount of time is very, very limited. So there is the latency into that, baked into that consideration. And if it's human-driven, you need also the latency of the person to do something, right? So that part is also baked into that problem. So now you can kind of understand that there might be a couple of frames within which we not only have to infer from each individual sensor that is in the intersection. Let's take intersection as an example. We have to not only infer that, we have to get an agreement between all of the sensors, which will not agree. So suppose radar has a very small cross-section on pedestrians, right? Camera sometimes classifies pedestrians, sometimes it doesn't. We don't know why. LiDAR, it's expensive, and again, it has a short, cross-section. So all of these problems play a role. So ultimately, when you're getting down to it, I don't think, aftermarket devices are great because they can give the reliability, right? But if you are just looking at trying to classify from sensors, remote sensors, we are still quite a ways away, I feel like.
Oh, go ahead.
So in a little bit to respond, to a couple of the statements that are up here. In terms of sensors, we can mount a sensor. Well, first, let's go back. First, we need to define what the requirements are for each individual sensor deployment. And whether that's a big intersection, a small intersection, a freeway, we need to define how far we want to see out and with what accuracy we want to detect and classify things. Once we get that, I've been talking within the OmniAir side of things as far as sensor certification or sensor system certification, because it may be a combination of sensors that gets us to where we want to be. And then you talk about sensor fusion, and that's the whole sensor fusion type of thing to get you the information about what's going on in that field of view. Once you certify a sensor suite or a sensor system, then you install it, and it's configured, it's calibrated, and it's great. And then over time, things change. And you don't know that they're changing because it worked great on day one and you're still getting data and you're not really taking the step to validate that data. So I think data validation is ultimately where we need to go in the future for sensors. We need to validate our infrastructure data, our infrastructure sensor data against vehicle sensor data. You know, are they seeing the same thing? And this is where the SDSM message comes into play. Are we seeing the same things in predominantly the same locations from multiple different sensor systems? And if we are, great, everything's working great. But then if there's one system, whether it be a vehicle or infrastructure system that sees something different, then that owner of that system needs to be notified and say, hey, you need to recalibrate your system because things aren't off. We don't want to be sending pedestrian warnings or bicycle warnings or things, vulnerable road user warnings with incorrect locations.
How many intersections are we talking about? Because then we have to think about every intersection is unique. So the same system which works for a four-way crossing, which is straight, will not work if one of the roads is curved, and then if one of the roads is a main road and another one is a side one. So you start seeing how the complexity keeps on growing with every intersection that you are working on, right?
Right.
So it's that's the problem. It's a scaling problem, right?
Right. But if you're working with bad data,
oh, there's no chance at all.
Right.
Yes.
And then the second thing to the ASD comment that Suzanne made, aftermarket safety devices, we need to get to a point where these products are affordable and commercially available. 2026, I like that stake in the ground. Because we have a deployment on US 33. Everybody's probably heard of the US 33 Smart Mobility Corridor. It included a county and two cities. And we deployed roughly 150 onboard units into public citizen vehicles or private citizen vehicles. And feedback that we're getting now as the project's nearing close, we're actually going to get safety benefit data. I know that's something the USDOT has been asking for, so we're going to have a report that kind of gives our interpretation of the safety benefits of the technology. But I received an email from one of the users saying, "Hey, I live in Dublin. I had this equipment installed. I drive around Dublin. I love the technology. And when I went to Marysville, I was shocked that it worked in Marysville too. And will this technology still work after December?" And it's DSRC technology. We installed DSRC, and we installed DSRC OBUs because that's what we had there, and we wanted. Technology doesn't matter about the safety benefits. That's the goal of the project, was to measure the safety benefits. So we thought, regardless of the technology, we can at least get the safety benefit information out of this project. And so now we're left with, these people want this, but how do they buy it? Because the government can't buy a OBU for every private citizen vehicle out there that wants it. So looking towards commercialization, I think, is another strategy that we all need to be focused in on.
Yeah, there was a myriad of things there, and but what I'm taking from it is that there is an inherent desire from the public, and they see the benefits of this, and clearly cyclists, you can imagine, there's tons of data, how it gets transformed into useful information, but then everything. To go back to aftermarket safety device, they have to be fit for purpose, right? They have to have the performance that is needed, and not have false positives or false negatives. And so there is a definite balance between performance and cost. I guess we need to figure that one out.
Well, and to respond to that, I think it could be application specific. So you could have a device that supports these two applications really well, and that's a benefit to the public.
Yeah.
And if they wanted to spend a little bit more, maybe they get a couple more applications, based off of requirements for those applications.
Let me touch on applications, which is my next one. So Frank mentioned applications earlier. OmniAir, we're looking at with an applications working group. We have to figure out what we do with that. Is it certifying or functional testing? Maybe some of the comments from the panel would be welcome here. In terms of, for me, applications is the culmination. All this stuff has to work. The file layer, the stacks, the applications, the supporting infrastructure, the geolocation, everything has to work for the application to work, right? So it's a good test, but everything has to work. What was your opinion about testing applications? Do you see a certification? Do you see just a functional testing? Yeah, it works and let's go. I guess that's the hard question, but maybe comments from the, I'm talking vulnerable road user, any application you can think of. But any comments on that?
Can you go first?
Go ahead.
Go ahead. I was going to say, part of the way that we should be thinking about application is beyond kind of even the binary on-off, is it working? But also, are the applications themselves considering the real-time kind of pedigree of the data, the sensor fusion or whatever? In other words, like, how is the fidelity? How is the latency? How reliable is that data? And can you modulate within the application itself the actual user experience that's ultimately delivered based on that real-time assertion of pedigree and reliability of that data? That's something that we think is kind of key, and it may be up to the individual companies to kind of deliver on that, but I even think that testing bodies like OmniAir should consider how those factors are taken into account, especially when you talk about the complexity of sensor fusion at the intersection, interoperating with C-V2X, interoperating with network-derived UU communications. How do you maybe interpret that in real time to deliver as useful as possible an end-user experience?
We'll come back to that, Kellen. I'm keen to get other panelists, so I'll come back to that.
Thanks. Yeah, so from an interoperability perspective, Bill, you were here last October when we did the 5GAA demo showing various collision warning applications over UU with 2 different application providers, 2 different MNOs. So I think there is a need for those applications to be able to work together, particularly for safety use cases. What is that certification methodology? I don't know, but it's something that I think I applaud OmniAir for starting to look at it. And LGE was one of the participants. Comsignia was one of the participants. So being able to show that, not just from MNO interoperability or OEM interoperability, but Comsignia's application is able to communicate to LGE's application using our network, and they're both able to deliver those relevant messages.
And also over another network, right? Verizon. So
exactly,
guys were,
exactly. But the user behavior aspect. There has to be consistency of expectations in terms of what the user behavior is going to be, because if you and this is maybe part of the standards, maybe part of like UI development work, but you have to make sure that you're not surprised, right? If you're expecting an alert to be delivered in one fashion and you get something different, we need to keep that in mind as well.
Any other comments?
I'm going to remain agnostic on the question about whether there should be certification testing or not. I really like the term that Frank used called application validation, because gives you a bit more flexibility. But I think you're getting to a really key point, and the reason I like the concept of the working group here is that there's a base set of performance metrics that everybody should be able to meet, and then you've got these other considerations on top of it. It's not just meeting the performance metrics, but it's the demonstration in real live environments that this works the way we expect it to. And then we can think about how to tailor it for the human experience. You know, what are they expecting and how to be consistent. So there might be aspects of it that you all eventually decide really should be tested and certified in some respect, but maybe other aspects that are just more validated and demonstrated when what comes out of it.
Any other comments?
And I'm going to argue for certification, but additional certification of applications. Because, well, I think before we get to certification, though, we need to have some sort of common understanding of what the messages and the data within those messages is going to be. And it's got to be consistent. We're successful here at OmniAir at the Plug Fest because we have a technical Plug Fest technical committee that sits down and defines what these tests are and what the structure of the message is going to be. But early on in the days of the 33 corridor, sat down with multiple different vendors and manufacturers and laid out our expectations. And each one of them came back, well, we need this part of the message to operate with us. I mean, the other was, we need this other part of the message to operate with us. And I said, guys, I'm not going to develop this humongous message to satisfy all of your needs so that we can all come to the same common output. So getting down, and I think this is what drove DriveOhio to lead the standard operating principles development for curve speed warning and some of the lane closure and reduced speed warnings, was we needed a consistent message with consistent structure and consistent data that we can say, this is all you're getting, this is enough, develop your applications around it.
Well, I applaud that initiative for sure. I have a few more questions, but I feel I'm hogging the microphone. I'm just going to take time. Does any questions from the audience? So I see a couple of hands go up. If there's microphones that could go around. I think.
They were focused on the SPAT, the red light violation warning with the SPAT, the pedestrian and crosswalk and pedestrian conflict warning, and the curve speed warning.
That's your question? Yeah. There was another hand up. Yep, go ahead.
So I just want to make a comment about this application certification versus validation, right? I think that you have to break it down into multiple areas. So one is your feedback to your user, the person using the car. And I would like to compare that to the MUTCD, right? They have some specifications. Hey, this is what you need to show on your sign, right? So some of those would be the requirements, right? And when it versus a certification, it's a requirement. When you're going to give this sort of an alert, this is how you got to message it, and it's got to show up in some specific place, right? So that would be some route to take where it's in the requirements. Certification versus validation, every app, we know how difficult it is. Somebody touches it, you have to certify it again, right? So that becomes a pretty intense certification process versus if it's just a validation, it's a little easier. So just more to comment. I'm not sure if the panel there has any more things to add about certification requirements and obviously validation.
I think that physical validation is probably more difficult just because, let's again take my favorite thing, sensors, right? You can a slight different change. You were talking about calibration, right? Calibration under what circumstances? Is it day? Is it night? Is it cloudy? Is it raining? Is it snow? What are the external conditions? How much of a wind is going on? Is this mounted on something which is swinging, or is it completely static? Even if it is static, how much of this vibration is going on? So, like, what conditions are we testing it on is not very, very much set in stone. So validation, I think, is not going to be easy for such a system on a large scale. Again, if you want one intersection, not a problem. You can get somebody out, it'll be 5 minutes, and they can do a calibration of sensors and get all the data and do a very good job. But when you're looking at 10,000 of these, that's no longer in place. So how do you do that in an automated fashion is a challenge.
and maybe to add on to maybe some of your question around the MUTCD, when we developed our operating principles, we didn't specify, we specified a minimum distance from the sign, or a minimum distance from the event that the warning had to be displayed. We wanted to leave it open. They could display the warning much farther in advance. We didn't want to specify the types of warning, because that was expressed to us by the OEM and the industry, and that creates that allows them to be competitive. So want to maintain that competitiveness, and also provide some minimum level of expectancy.
Yeah, no, I think it's going to be a challenging topic, and I think we're just in the start of figuring out that, we're trying, as I say, the applications, everything has to work, and we're trying to get everything else to work, but now we're getting to that now applications, but how you certify it, test it, validate it, all the different scenarios, different speeds, different conditions, that's definitely a challenge. Which goes on to my topic on testing. Testing was the topic on the previous panel, but I'm interested as we look at the future applications, different scenarios for vulnerable road users, different scooters, bikes, joggers, different speeds, there's different things. And testing is the fundamental premise, because we have to trust that these things are going to work. And testing, from Keysight, obviously, testing is a good thing, but we need to make sure these things work before the public or trust goes. And if trust goes, then I think everybody's going to be very disappointed. So where do you see in the future the role of testing? And maybe I'll touch on a couple of things like digital twin, virtual testing. How do you see that playing out in the future? And what trends do you see? Just open it out to anybody want to pick that up.
I can talk. Well, virtual testing. So we are doing a lot of work on the simulation environment called Carla, which is like a photorealistic simulation environment that is developed on Unreal Gaming Engine. The good thing about virtual testing is you can do infinite simulation. The bad thing of virtual testing is you can only get certain amount of variability. So how do you induce variability? That's the question, right? You can develop great digital twin models of certain intersections. Again, the problem is scaling. You can do different kind of scenarios. You can see under what conditions do you get those collisions, where there are conditions for crashes, under what speeds, if you have VRUs, what kind of VRUs. But again, you cannot change how the VRUs look. That's a very difficult case. And real life, you get the corner cases, and that's what you want to test for, actually. That's what you want to kind of, validate against. But that's what virtual testing doesn't give you, right? And so there is this kind of gap between what the simulation or the virtual testing gives you and what you want to test for.
And I think a lot of those simulations will really be refined based on the real world testing. In terms of a trend, what I think is, because I think all of the different types of testing are needed, but what I find really interesting are certain infrastructure owner-operators looking to create the corridors or to create the parts of their installations as actual test sites. So I know that Utah has been setting things up and wants people to come take products and come and deploy and see what happens as you go through there. Texas is looking at a very similar type of a setup from around the north central Texas area down through Austin. They want to be putting things out that allow people to come and see what happens when their technology goes there. And then of course you've got these proof of concepts like you have up in Bellevue, Washington, to both sort of create a system to put it into actual work to see if it works, but to be able to collect all that really great data to refine how it works and then figure out the scalability aspects as you go from this intersection, which is configured like this, to one that's configured differently. How do you have to reconfigure? What do you have to do? And I think all of this great information feeds back into standards, which then feed back into test procedures that places like OmniAir can run with and really kind of help refine digital twin concepts, which, you know, everyone is taking off with their digital twin around the world. And I think from a performance perspective, it's really great to have something running in parallel with your actual system so you can try things, and if it works, you can go into your system and you can start to tweak things. But you're right, there are great limitations with that digital twin concept, so you really have to kind of combine this all together.
Mm-hmm. Yeah, and I'll just, since you brought up Bellevue, I mean, I think we're fortunate. We're headquartered in Bellevue, Washington, and we have an innovation center, what we call the 5G hub, where we can test all kinds of different applications. We can do bench testing. We can use all the different spectrum that we have access to. And we have a very cooperative, forward-thinking city that now is allowing us to use physical deployments as a field test bed. So as we bring in more partners to the ecosystem, as we develop new use cases, we can test it in our innovation center, and then we can deploy it in the city because, as I said, they're very cooperative, they're a collaborative working relationship. I'm also encouraged now because of the work that we did again at Mcity last October for 5GAA. USDOT was there, Federal Highway was there. They have expressed an interest in understanding how to replicate that scenario at Turner Fairbank and McLean with the objective of creating a guidebook that can be delivered to state DOTs, local transportation agencies, and in cooperation with Verizon and other ecosystem partners, we're helping Federal Highway develop this test plan for various use cases that will continue to be extended upon. But it's all for being able to help other local, state municipalities to be able to deliver these use cases.
Okay.
I want to add on just one thing.
Sure,
so it's a different
sorry.
perspective, and I hope that I'm not accused afterwards of being the go fast and break thing when it comes to human lives.
You're a cyclist. That's what you do.
That's right, yeah. I think it's very important in the broader context as an industry that we not let the ideal of perfect and the edge cases become the enemy of good. And let's not lose the forest for the trees. And I'll bring up just a base statistic, again, looking at, let's call them mobile vulnerable road users, right? So people that are using maybe 2 or 3 wheels to actually locomote. The majority of those folks that are injured or killed on our roadways are not killed at intersections. Something like 60% of them could be saved with nothing more than basic, here I am, there you are awareness. Bike ahead, car behind. That's all that you need to potentially save up to 60% of people that are already moving today. So there's this low-hanging fruit element to it that we as an industry should remain focused on deploying as quickly as is possible, especially when the consequence, let's say, of a false positive is relatively low, assuming that you've worked with human factors and things like that, so that maybe it's just an icon or a low fidelity notification or whatever, but just raising awareness can begin to save lives today. So I would encourage us not necessarily, what we should remain focused on the edge cases. And I'm not disparaging all of the work that goes into testing and validation. Let's not lose sight, and let's not lose another 10 years of our time not deploying this technology because it isn't perfect today.
Yeah, loud and clear.
Maybe one final comment, and then you can close it out or whatever you want to do it. I want to key in on one of Jason's remarks earlier today. The purpose of OmniAir is to ease the burden of deployment, both financially and technically, on the deployer. If the deployers don't have commonality, I'll say this again, if they don't have commonality in the messages that they're sending out through these devices, and their commonality in the expectations for how the applications will work, any testing that we do here is for naught. So we can call it validation, we can call it certification. I think when I talk to my other IO counterparts, they're just looking for a sense that the applications that they're interested in will work at some level. I'll just leave it there.
No, I couldn't agree more. Yeah, I had 2 more questions, but we're running out of time. I'll make one closing remark and then we'll close it out. my analogy and the reason that Keysight are a big supporter of OmniAir is that I look at the mobile phone, but I'm old enough to remember before we had the super duper phones we have. And there were stories where a plane would arrive at an airport and everybody would switch on their mobile phone and they would pull the network down. Yet today I fly all over the world, which isn't great environmentally, I get that, but I expect my phone to work everywhere, anywhere. It's just, and when it doesn't work, that's the exception. I thought, what's wrong with this thing? You know, because and we need to get to that. And the reason is not that by luck, it's hard work on the terms of the mobile devices, network operators, all the testing, certification, there's a ton that goes, but that's under the hood, right? It just works. We need to get there. And things like OmniAir are part of the enabler to get to that. It's ubiquitous and trustworthy devices. So, but I will leave it there. I guess I should. Any more questions from the audience? Oh, there is one. Could we get a microphone? Yep, it's coming. Thanks.
Hi. So when you say that OmniAir certification is supposed to reduce labor and cost on deployers, right? But what are you testing exactly? Are you testing the hardware or the software? And the new software releases, for example, is it when you certify a certain device type or a certain generation of this device type, does it guarantee that all future devices or all updates, whether hardware or software, are covered under this certification?
No, you're certifying for that device, for that period of time, okay, for that release of that standard.
Okay.
There'll be subsequent releases that cover additional capabilities that you would have to certify against.
So any new software releases, they need to go through the same process and to be recertified again to make sure that it's compliant.
You would have to discuss that with Randy and Jason.
Yeah, but it's a good point, and you're chasing your tail every time because things evolve. But at some point, you have to draw a line on. So our equipment changes, obviously, but our certified equipment is certified with certain firmware level, hardware level, and it's documented. And we test devices in test labs against a certain level. In 2 or 3 years' time, where this firmware changes, we have to get recertified. So, and that's a decision that OmniAir need to make in terms of recertification, but that's an active and ongoing process. Okay, big zeros are here. I would just like to say thank you very much to my panel. I've enjoyed the discussion. I've learned a lot. Thanks for listening, and just give a round of applause to the panel.
Thank you.
Wow, what a great day. I feel like I've got all sorts of ideas just popping off my head. I'm sure you do too. Just to answer the question briefly, yes, we do have a recertification program. We have a surveillance program, very active. We can go into the details with you when you come over to Mcity for the tour, which is our next stop. Berkinda in a few minutes is going to give you some instructions about what's happening the rest of the day, how when the bus is arriving and leaving, and what we'll be seeing. But I just wanted to first thank all of our speakers and all of our moderators who did a fantastic job. We can get an applause for them one more time. I would also like to thank our gracious hosts, the University of Michigan, especially the Transportation Institute and the folks at Mcity, College of Engineering, for being just wonderful partners for this PlugFest as well as for this workshop. I'd particularly like to thank Dr. Jim Sayer for suggesting the football in the first place and bringing us here. I'd like to thank Francine Romine and her team for countless hours that they've been putting into planning this event. I'd also like to recognize the OmniAir team members that are here. Berkinda Cantlow, who is roaming around with the microphone, Ryan Hall, who has been trying to get you to give a little bit more money to help support OmniAir. Would you guys like to stand up very quickly? Berkinda, Ryan. And of course, the rest of the team that is that's working remotely and at Mcity right now to help support this event. Thank you all for being part of this. I hope we can continue this conversation at Mcity and at the reception at Zingerman's Roadhouse. But one thing you'll see that will follow from this is we will have demonstrations of field and bench application testing that we've been doing for a couple of Plug Fests now. And we think this is applicable not just in the PC5, but as things move into to UU transmissions and other types of RF communications, we think this will be relevant. Would love to have your feedback and thoughts on that and participation. And if you have an interest in getting involved, rolling up your sleeves, just find me afterwards. And before we have Ms. Cantlow, I believe that Suzanne Sloan wanted to talk about another listening session that we're going to have on second report in order.
So things have been evolving as we've gone through this Plug Fest. Because everybody was really in the room yesterday when we held that one session, and thank you all for staying, we're thinking it probably isn't worth running a whole additional presentation again. But what I'm going to do is come by at about 9 tomorrow and stay through probably about 1:30. And so if there are folks who missed the presentation who want to go through the whole thing, come see me about 9:15, 9:30, and maybe I'll get a group of folks together and we'll run through the slide deck again. But if there are folks who want to talk about just one piece of that and offer comments, having thought about it for a while, let me know so that we can schedule a little bit of time and I can get your additional input. So we won't have a formal session here or over at Mcity, but we'll just do it more informally tomorrow. That's okay. Okay, thanks.